My name is Miriam Turk. Good afternoon. I am co-founder and CEO of Clear Blue Technologies. I am joined today by Jeffrey Adams and Jonathan Van der Veen. I believe we'll be also having Peter Mikas joining us in a few minutes to give you this presentation today. Jeffrey and Jonathan, can you see my screen for the full presentation?
Yes.
Okay. We are always keen to have questions from everyone in the audience, so please post your questions in the chat, and at the end of the presentation, we'll go through any of your questions. What we're going to do today is talk a little bit about solar streetlights as specifically relates to departments of transportations and energy companies and how they might be looking at this market and the requirements that they need to meet. We're going to be talking about what the current options are, why this is starting to become a trend and something that's moving from just something that you did on the edge of your infrastructure where you had a problem to, I believe, 10 years from now, every light will be going as a solar street light. We're going to talk about how off-grid solar streetlights work and function, why they're different than grid lights, and what you need to do it in order to be able to deliver a utility-grade solution. And then we'll talk about some installation projects and some real world examples that we have. So in terms of a streetlight, just to step back a little bit, every energy system that you have consists of three components: energy generation, energy transmission and distribution and storage, and then load control. In a traditional grid-tied street light, the first two items, energy generation and energy distribution, transmission, and storage, they're handled by other guys, other departments, or other, entities. But in a solar street light, you have an entire mini electricity system, just like the grid, except for in miniature. So one of the things that we feel customers start to become aware of is that no one would ever build a power grid without the operations management and robustness that you have in an entire electricity grid. And oftentimes people start off with, well, it's a light and it's a light. No, it's a light that's connected to a grid utility system, and it's a solar light, which includes an electrical system as part of it. So to have reliable long life solar streetlights, you're going to need ongoing management and control of that system. I think the other thing that it's important to understand is that solar streetlights have a consumable. They have batteries, and batteries have a limited life. And the day you start with the battery, the tank is full. And then depending upon the technology, the line might be different, but it is a declining line over time. So how you manage that consumable product, the batteries in your system, will materially be able to help you affect the long life and the performance. So how do you get maximum uptime? You make sure you've got lots of battery capacity. And how do you get maximum system life? You make sure that the batteries don't die a quick death. When we look at the North American marketplace, you actually have quite a very unfriendly environment. You're not using heating environments and buildings and enclosures to manage the temperature and the exposure. You're actually dealing with extreme weather. You're going from 7 hours of daylight in December to 17 hours of daylight in June in the northern United States or in Canada. You're also dealing with minus 30 degrees Celsius or minus 20 Fahrenheit overnight in the wintertime if you're in North Dakota. And then, 100 degrees Fahrenheit is a cool day in Texas, could be much warmer than that. So when you're looking at solar street lighting at scale, in other words, I want to do hundreds or thousands of these as part of my long-term infrastructure, and we get infrastructure grants, and then you want it to run for 20 years. You need to have an affordable, low-cost solution. And grid-connected lighting is becoming very expensive, and I'll talk about that in a while. The other part of it is that you have to be able to, in most applications, not every application, but in most applications, meet design specs to limit liability, to ensure that there's safety and performance, et cetera, et cetera. And it can't be, I hate maintenance so much, I actually typed the word twice. It can't be something where you've got to go visit the pole. I can remember when we first started this company, we talked to the first customer and we said, he was an early adopter and he said, I don't have any problems with my systems. I said, well, how are you handling your batteries in the wintertime in Chicago? And he said, that's no problem. We sent the service crews out every fall and they take the batteries out of the pole and they take them to the shop and they charge them up and then they go back out and recharge them. That obviously doesn't scale. So in order to be able to meet what you need to meet, you've got to be able to do it with zero maintenance and it's got to provide a good service. So this is the first time we're giving a presentation to DOTs specific as a sector and power utilities. And the reason we're doing it is because we believe that solar street lighting is now hitting prime time where there's a use case for every installation. And the reason is that there's been basically two big trends. The first is the trend in solar costs. When you look at solar energy, the generation cost, we're now down to below 50 cents a watt. And, solar panels just by themselves can be 20 cents a watt. Whereas not too long ago, you were paying $1, $2, $5 a watt. So you're talking about a 90% drop in the cost of solar energy. One of the biggest costs in any electrical system is energy storage in the grid and even in an off-grid system. And energy storage costs have dropped by 70%. So solar's gone down by 90%, energy storage has gone down by 70%. And then on the other side, we have LED lights. And LED lights have gone from 80 lumens per watt to 170 lumens per watt. So if you look at a DOT infrastructure and you're looking at a residential road or a collector road or a major road, back in 2018, when it was 80 lumens a watt, you needed between 70 watts and 206 watts of power to power that light. That's now cut pretty much in half. 34 watts for a residential road and 97 watts for a major road. So when the power consumption has dropped by 50%, at the same time that your cost of the energy system is down by 70, 90%, you get to that inflection point where all of a sudden the dog really hunts and the cost of solar streetlights becomes competitive. So the reason why we are talking today and hoping to work more and more with departments of transportation and energy utilities and the ecosystem around them that support that market is that solar off-grid lighting is now lower cost than grid lights. You're eliminating the need for trenching and cabling and distribution and connecting with meters and breakers, et cetera, to the grid. You're reducing and eliminating significantly the construction disruption if it's a retrofit. You're also building resiliency and defense against forest fires, floods, power outages. We've been seeing lots of fires that get caused by forest fires in Maui, certainly in northern Canada right now. And having an off-grid solar system, the cabling doesn't get destroyed when the fire jumps over the road. Even when it's buried in ground, if it's a grid distributed system and a forest fire goes over it, you're burning those cables and they have to be replaced. And stuff happens, but the lights are still on. And at scale, you need to know that this light is going to perform to the specs that you need. And that you're going to meet the EaaS compliant levels of utility grade lighting that are required. So how do you get something that's not just in a park or, in all those other areas where you have some flexibility with what you're doing, but how do you get to utility grade, EaaS compliant, smart solar off-grid solutions? Well, what does it mean to talk about utility grade? So it's got to be professional infrastructure that is something you can deploy. It's got to have high reliability and uptime. It's got to have a 20-year life. It's got to be robust construction. It's got to comply with the standards. Remote management and control is something that's mandatory. These are all individual mini electricity systems. And by virtue of the fact that you're not connected to the grid utility, you are all of a sudden a mini grid utility operator. You have to have the tools needed to be able to deliver that. It's something that's got to be scalable. I've got to be able to do it for small projects, for big projects, for small local residential roads to bigger main roads. It's got to be efficient. It's got to have not just a lower total cost of ownership, but a low upfront cost and a low total cost of ownership. And then it's got to meet the regulatory and safety certification. So Clearblue as a company has been focusing since the day we started the company on these types of requirements. Um, and as the world has caught up with us and said we have to have these requirements, the functionality and capabilities of our product went from being something that was kind of nice to have to something that we can't live without. On the IES side, there are IES RP8 compliance standards that you need to talk about around lighting levels, design methods, uniformity ratios, all of those kinds of things. I think the thing that I would like to say is that for those of you who are involved in the ecosystem, I kind of use the cell phone story to describe this. 20 years ago, where we were all using landlines and we were having a conference call with or talking to our customer, we would never have envisaged the point where, oh, my line's bad. I've got a bad signal. It's dropping off. I'll disconnect and I'll recall you back. But when we got cell phone services, cell phone became so compelling that we modified the standard to say, you know what, even though I need 100% uptime, if I have to drop the call and reconnect, it's okay. So even though IES RP8 compliance is a critical requirement, there are a lot of situations where the customer will compromise and say, you know what, maybe I can't have 100% uptime 100% of the time, for the next 700 years. Sometimes they're willing to modify the requirement. And that's okay. We have a lot of flexibility, and I believe that DOTs and energy utilities are working there as well. So sometimes you have to have full 100% RP8 compliance, and sometimes you don't. But in our experience, whatever it is you decide to provide as a service level to that customer, you have to, as a DOT or an energy utility, be able to deliver that service level. So if a customer comes to you and says, you know what, I know I'm supposed to have an IES compliant light for a residential road that's got, 34 watts at 170 lumens, I'm willing to go with 28 watts, a lower lumen wattage or, a little bit of dimming. That's okay, as long as you know that you're actually going to be able to deliver the modified service. So what we don't believe in as a company is that you just install it and you get what you get. That works in some situations, but at scale for a power utility or a DOT, you can make the decision as to what you're requiring. I've got to have full compliance, except for in the middle of a snowstorm in December when there's no, we've had 5 days of a storm. Then it's okay for me to have degraded service. But you must have controlled performance. Whether it's 100% compliant or not, you have to have control and a good understanding of what you're able to deliver and what you can provide. So what do we think the answer is? The answer is that you're going to have thousands of solar streetlights with thousands of mini electrical grids. You're going to eliminate tens of thousands of kilometers of cabling that is just the transmission infrastructure is the worst nightmare for everybody. And if you can get a technology that can manage at scale hundreds and thousands of systems, if they have remote management and control, not just monitoring, and they can do remote maintenance, if they have a critical energy forecasting tool, it's like an electric vehicle or even a gas tank. I remember the days when the tank would get to quarter tank and I'd know that I'm gonna, beep, the line comes on, I got to replace the gas in my car. Now the thing says you've got 60 miles, 50 miles, 40 miles, 30 miles, and sometimes I use that. I get down to 10 miles before I get gas. In order to provide a reliable energy service and a reliable lighting service, you must have the ability to forecast what your energy is going to be, no matter the sun, the cloud, the smoke, the cold, the hot, the long days. And if you can use that energy forecasting properly with a good platform and a good engineering team behind the platform to deliver that, now what you say you're going to deliver, you actually deliver. I'm meeting RPA compliance, or we've agreed with the customer that we're going to be at 90% of RPA compliance, and we're actually delivering that. And of course, we all know that there's a big difference about what we're doing out in the field than, what we're doing in the lab. And one of the last pieces of Clear Blue you're going to hear us talk about is I call it the getting naked piece. It's one thing to just say, yeah, my light's going to be perfect and everything's wonderful. No, no, no. It is another when a customer calls us up and says, well, we're not really sure whether this is performing. And we say, well, actually, you've had these systems installed for 5 years, since 2018, and let me show you the performance of that system that you've had. So because we monitor, manage, and we're involved in the ongoing operations of the systems, we're working with you and talking to you on an ongoing basis about how they're actually working and what they're actually doing. So our smart off-grid solar solution consists of a couple of key things. The first is, lighting is kind of like going shopping for dining room chandeliers. Different applications, different layouts, different type 1, 2, 3, 4, et cetera, et cetera. You need complete flexibility to work with any light. And that's a key mantra that we have. So we work with any light. We've built into our product the ability to integrate and connect to any LED street light out in the marketplace today. We've added on to that the capability to remotely manage and control the system, to have a comprehensive platform that it's not just a web app and I'm looking at this one device and how's it doing. No, it's sort of I call it the NOC, the Network Operations Center. You've got a control center of engineers who sit down, they look at 15,000 systems every Monday morning, or Sunday afternoon if it's the weekend shift, looking at the systems and seeing where there are issues and what needs to be addressed, but more importantly, what issues are coming in 3 to 5 days that we need to do preventative action. So energy forecasting, looking forward and knowing whether you've got issues coming. I'm going to get to the gas station before it gets to 0 miles per hour. We're going to deal with the system to ensure that it can manage through whatever it is thrown at it, and that you can meet your RP8 or modified RP8 requirements without having some sort of an automated, miss the mark. It just does whatever it needs to do as it aged. One of the key things that I've talked about, and I just want to repeat here, is everything we do with Clear Blue is delivered with our energy as a service model. So whenever you buy a one-time solar off-grid street light, and we have a couple of different products we'll talk to you about in a minute, included in that product is the first 3 years of our energy as a service. And our energy as a service is two pieces. One, it's at scale management platform that allows you to manage thousands of devices across multiple use cases, installations, and applications. So it's a network, management system platform, together with the detailed tools that lets you dive down into any specific one to find a troubleshooted issue. I've got a cable connection problem. The battery fuse blew. The battery terminals have sulfated. The light is blown. The solar panel's broken, whatever it might be. And we manage it on an ongoing basis for our customer. So after the first 3 years, you can renew the service or not. But if you do renew the service, then that issue of that consumable battery, this died or that thing had a bad death, et cetera, that's all covered by us. So a lot of people will say to me, well, isn't that a warranty? And again, I'll go back to a car. So if I have a really long extended warranty package on my car, no problem with that. But if the battery dies or the brakes need to be replaced or I need new wheels, the wear and tear stuff of the car, that's ongoing maintenance that you have to pay for. In the case of ClearBlue's Energy as a Service, that ongoing maintenance, more than just warranty, of the battery that's dying slowly and will eventually have to be replaced, of the consumables that need ongoing management replacement because they get to end of life during the 20-year life of the service, that's included in the fee. So if the battery dies after 6 months, it's a ClearBlue problem, not a customer problem. That's what our energy as a service is. So just to talk a little bit about the technology, we really focus on three key things from a brand promise perspective. We're going to make sure that you get the most power, the most light for the longest period of time. That's maximum uptime. We're going to make sure that this system lasts 20 years. And oh, by the way, if the battery dies after 2 years and the charge controller needs replacement after 3, and this happens and that happens, that's all on us with EaaS. We put our money where our mouth is, we take the risk. And then the last piece is almost 90% of the problems happen at install and maintenance. I love the story of, I used to have a Northern America story where somebody installed the solar panels facing north, and you kind of laugh at yourself and go, well, why would you not put the solar panels facing south? I had a story in Africa where the installer actually put the solar panels on top of each other. So one stacked on top of the other. That's a stupid extreme story. We actually had, I remember in Algonac, Michigan, we did a wonderful project. I don't have a picture here. The customer installed all of the street lights in June and they went fantastic. They were running wonderful. They were performing great June, July, August, September, October. In November, we called them and said, you guys installed the solar panels wrong, and now you're not going to make it through the winter. We knew what the problem was. It was just an angle. That particular model that ClearBlue has a variable angle solar panel. And it was a maxed out system, right? It was right to the edge and it wasn't going to make it through the winter at all. So making it easy to install and maintain and us providing the support to make sure that the installer who goes and does it right is something that is part of our service. And the two key things that we do are key differentiators: energy forecasting and management. Oh, we've got the cloudiest, darkest January we've ever had, where we only had 2.5 days of sun for the entire month of January, needing energy forecasting to be able to manage through an extreme weather situation like that. And then troubleshooting and remediation tools. When those 30 Algonac, Michigan systems had problems and the lights were not going to run and the battery was getting low and then the battery was dying and we could see all of this coming, we were able to use detailed, quarter second and 5 second and 10-second data to understand that the problem was the angle of the solar panel. And we told them it's the angle of the solar panel. They weren't replacing controllers, they weren't replacing batteries, trying to figure out what was wrong. So our key differentiator are those energy forecasting and management tools and the remote troubleshooting and remediation tools. So we're not doing a demo today. If you would like a demo, we'd be very happy to arrange that to be done. But I just wanted to show you that this is mission control where, if you are a large DOT in one of the states across the United States, or you're, Sask Power in Saskatchewan, and you've got thousands of these devices, your ability just to sit down and look at the entire network at a macro level, not at the individual level, is very key. It's also very key not to just say how it's doing today, but how did it do over the last 3 days? The number of customers who tell me that the only way they know that solar light works is they go to the site and take a look at the light at 3 o'clock in the morning. But also to look forward, what's it going to do and deliver? So what's the reliability? What's the real uptime? Are we meeting that? What are the actual extreme temperatures? We're going to talk a little bit about a project in Nevada. And turns out that one of the installations is at the top of a higher elevation and it goes down to -20. So I'm thinking, Nevada, Las Vegas, nice and hot and warm. No, no, -20, even in Nevada. No downtime, the systems are maintained. So this just gives you an indicator of the ability that we have to be able to manage it. One of the things that we do have is real-time management, so that when the installer is standing in front of the pole, we can actually work with him and remotely install, commission, and test. When an installer goes out and installs this system, he just has to reach out to our service team and we'll commission it and give him a check mark, say, yeah, you're good to go. You can leave the site. Everything's working good. So let's talk a little bit about a couple of real world success stories. We've had the pleasure and the honor of working with a number of transportation and energy utility companies. One of the ones we're going to talk about is Nevada DOT. So this was a project where Interstate 80 is being upgraded and developed at each intersections, where you have off ramps to local towns in the middle of nowhere. You need off ramp lights, et cetera, et cetera. And the high cost of getting grid power to that site from a few miles away was prohibitively expensive and logistically challenging. Again, would have thought it was a nice area, but very extreme weather. And one of the things about extreme weather is when you get these massive weather springs, -5 Fahrenheit, maybe that's not so bad. But when you go from -5 to +50, in a period of 2 hours, that can have an implication. And obviously, if we're talking about Interstate 80, it's got to be autonomous, reliable, durable, and there isn't going to be another budget to replace those lights for at least 20 years. So it's got to be something that lasts for a long time. So the results, great uptime, meeting the performance standards of the product without any sort of automated in the middle of the night, we cut the thing down by half. Enhanced safety and visibility, which is the key driver, and a reduction or elimination of on-site visits. It's not to say that you don't need an on-site visit. One of the things with solar streetlights is if you do need an on-site visit, then you got to go back after a few days to see, did it work? Is everything still working great? Or 3 months later, it's the winter time, is there now shading? So eliminating the need for maintenance on site, and then when and if maintenance is required, we know what the problem is, we've troubleshooted it, we've diagnosed it, we tell you what you need to do it, and you can schedule it as maintenance. This is an example of some of the photos of the installations for Nevada. Want to talk about a couple of other projects. So this is the American Parkway in Allentown, Pennsylvania. And what's really wonderful about this project is this was an existing roadway that had no lights. So if you think about the construction implications of having to pull a cable and do construction all along the road versus a couple of hours, drill and drop a pole, get it up and running, move to the next one. Instead of a few weeks of construction disruption here, a significant savings. And of course, if there's all this concrete and paving and on ramps and off ramps, getting grid power to the site would be cost prohibitive. So this is a project we quite love. I don't think I could make up something called American Parkway in Allentown, Pennsylvania. Another example would be North Dakota. I don't know whether you're aware, Canadians certainly will be, there was something we call the Humboldt bus tragedy. There was an entire hockey team in Saskatchewan, which is just above North Dakota, that was going through a rural intersection on some rural roadways. There was a truck coming the other way, didn't stop. Many young men died. About 3 to 4 months after that, we started a program with North Dakota where they put solar street lighting, single unit, at every or major, I think we've done a few hundred of them across the entire state. Now, I don't know whether there's any linkage, but it was a bit of a coincidence that, 4 to 5 months after this major rural accident, all of a sudden now you put in an intersection like this. And I think that, you know, once everybody in the area knows, hey, there's a light at the intersection, they count on that light. They say, I'm driving along the side road here and I know where the light is because there's an intersection. That light needs to be reliable and be there. So that's another project that we've done. Okay, so try to talk a little bit about technology in general, and what we think the requirements are and what we've learned about the marketplace and the projects we have. I just want to let you know that the very first project Clear Blue installed was in Tuscaloosa, Alabama, as a prototype for the Mercedes-Benz factory there in 2011, before we even started the company. We started rolling out production systems. We did a big project with IBEW, was really our first large project in 2014. And so we've been in this business for more than 11 years. And we are still managing and operating the systems that we did and installed. They're still working. They're operating fine. The power equipment is working great. We've done all the maintenance and management and prepare through Boston winters, through hot and cold weather. So we have some experience, and I didn't show my picture today, a little bit of gray hair behind us. So we like to think and hope that you would at least consider us for a project. So Clear Blue is a company that is focused on utility grade design and performance to meet large volume units deployed across an entire market. We only brought out our first all-in-one solar streetlight product last year. The reason we didn't do it before that, when many others were, was because it didn't meet spec. It wasn't until last year that we felt we could deliver an IEaaS compliant, high performing, high reliable light with an all-in-one light for certain applications. So it's always been our focus to make sure that everything we deliver has the performance capability, that there's ongoing energy management and delivery to manage and maintain the systems, that if you could just listen to my background, hopefully you've got some understanding that I'm, even though I'm the co-founder CEO, we take an engineering approach and a service and a design approach to make sure that the lights are designed and laid out properly. We have a lighting engineer who's fantastic, Peter, on staff, who also helps with product development, proper engineering design by location. The Nevada project is a great project. You just think about the fact that it's going to go to minus 10 Fahrenheit in the middle of the winter. That impacts the capacity of the system. So we look at it by location. We don't just give you a quote and say, Florida or Nebraska. It does the same thing. And we make sure that it's a robust mechanical electrical design to meet 20-year life. We have a product line that is there to address multiple applications. Our Senti all-in-one light, which we launched last year, is getting some very strong response out in the marketplace. One of the key aspects of that product is, you want the light to be oriented at the proper angle, facing down, not angled up, in the right location. But then you want the solar panel to also be facing in the right location. And if there's a tree in the way, you might want to angle it one way or the other. And so our patented turret design allows you to angle the light in the right way and then angle the solar panel in the other way by rotating the turret. For medium-sized projects, that would be, the word's not coming to me, but not residential, but up the scale. We have our CAMI product. Our CAMI product is a lithium-based. Lithium is very cost-effective. It's 1/3 the size. It has double the life of lead acid. So you put those three things together and it's just a slam dunk. It's also a fantastic technology because it's benefiting from all the electric vehicles and electric energy storage projects in the grid, in data centers. So the lithium battery cost has come down order of magnitude, and can support very high powered systems. And then we have our strata, which we also have a decorative one with a light arm, et cetera, which would allow you to put a wind turbine. And there are some use cases, the number of use cases is getting less and less and less, but there are some use cases where you would still want to use a lead acid battery. And all of those products are available either as a full system or as a power pack with a lot of flexibility to work with the light. So that's our presentation. Are there any questions from anyone that we should answer?
I'm not seeing any questions so far, but yeah, everyone, please feel free to post them in there. We're yeah, more than happy to answer anything that you'd like to know. Yeah.
We are recording this presentation and we will be sending it out through email to you to share. We would encourage, if you have any of your teammates that you would like to have us meet with, give a presentation, if you would like us to give you a sample proposal or dive into some of the detailed options a little bit more. Jeffrey, Peter, and Jonathan, who are on the call, is the Clear Blue sales team. And we would be most honored and pleased to be able to spend some time with you on some real project opportunities. If we haven't received any questions, I'm going to turn it over then and say we're finished. Thank you very much for joining us today. We really appreciate your time and energy, and we look forward to helping the DOTs and the energy utilities taking solar street lighting to critical mass across North America. Thank you very much.